Good day, Bayaus. Today, we're going to solve a problem from the book of Thermodynamics by Eunice Engel, Chapter 2, Properties of Pure Substance. A 0.5 cubic meter vessel contains 10 kg of refrigerant 134A at negative 20 degrees Celsius. Determine the pressure, the total internal energy, and the volume occupied by the liquid phase. So first thing we're going to do here is to identify the given, wherein the volume of our vessel is equal to 0.5 cubic meter, and the mass of our vessel is equal to 10 kg. And our temperature is equals to negative 20 degrees Celsius. So since refrigerant 134A at negative 20 degrees Celsius is mentioned, we're going to use a property table to identify the saturated liquid and the saturated vapor of the given temperature, which is negative 20 degrees Celsius. So our saturated liquid here is equal to 0.000732, and our saturated vapor is equal to 0.14729. So first is we're going to find the specific volume of the refrigerant and then plug it in our calculator, and we will get 0.05 cubic meter per kilogram. So to find the pressure, our pressure here is equivalent to the saturated pressure. So to find our pressure here is equivalent to saturation pressure at specified temperature, which is negative 20 degrees Celsius, is equal to 132.82 kPa. So if we're going to look it in a property table, we can see that negative 20 degrees Celsius is equal to 132.82 in saturated pressure. So next is to find the total internal energy using the equation mass times internal energy. So since our internal energy is not given, we're going to find it first using this equation. Internal energy is equal to saturated liquid plus the quality times the quantity of the difference of saturated vapor and saturated liquid. So since our quality is not given, we're going to find it first for us to get the internal energy using this equation. Quality is equal to specific volume minus our saturated liquid over the difference of saturated vapor and saturated liquid. So since they are all given, we're just going to substitute the given values and plug it in our calculator, and we will get 0.3361. Now that we have our quality, we can now find our internal energy. So substitute all the given value, wherein the difference between saturated vapor and saturated liquid is equal to 193.45. So plug it in your calculator, and we will get 90.41 kilojoules per kilogram. Now that we have our internal energy, we can now find our total energy by multiplying it to 10 kilogram. So plug it again in your calculator, and we will have our total energy equal to 904.1 kilojoules. So next is we're going to find the volume of the liquid phase, wherein the mass of our liquid is multiplied by the saturated liquid. So since the mass of the liquid is not given, we're going to find it first using this equation. Mass of the liquid is equal to 1 minus quality times the mass of the container or the vessel. So substitute the given values, and we will get 6.639 kilogram. So since we have our mass of the liquid here, we are going to multiply it to the saturated liquid, which is 0.007362 cubic meter per kilogram. Plug it in your calculator, and we will get 0.00489 cubic meter. So that is all for today's video. Thank you for watching.